Alright, you little mathematicians, we are going to talk today about prime factorization. So, prime factorization, that's a very definition-heavy word. So first I'm going to talk to you about what a factor is. You've learned this before, but a factor is a whole number that is multiplied by another number to get a product. So for example, 6 is a factor of 18 because you can multiply 6 by 3 to get 18. So that also means that 3 is a factor of 18 as well. Can you think of some other factors of 18? Good. 2, 9, and 1 and 18 are also factors. Okay, now prime factorization. The prime factorization of a number is you take that number and you write it as a product of prime factors. So again, even in this definition here, we've got another word that maybe we're kind of forgetting what it means. So a prime number. Prime number is a number greater than 1 that has exactly 2 factors, itself and 1. So here are the first prime numbers that we have in our counting numbers, right? Because prime numbers are whole numbers. 2, 3, 5, 7, 11, 13, 17, 19. Let's just pick a random one. 11 is prime because there are no factors of 11 except for 1 and 11. You can't get 11 by doing multiplication of whole numbers unless you're doing 1 times 11, right? Same with 13. The only way you can multiply whole numbers to get 13 is to do 13 times 1. Same with 17. Same with 19. Can you think of what the next prime numbers on our list would be? Alright, back to this definition. The prime factorization of a number is that same number written as a product of prime factors. So we're going to look again at 18, which we were talking about before. And here is 18 written as a product of prime numbers, right? We took 18 and we said, you know what, that equals these 3 prime numbers multiplied together. 2 times 3 is 6, times 3 is 18. We have factored 18 down into prime numbers. Another way you might see this written sometimes would be 18 equals 2 times 3 squared, right? Instead of writing these 3 times 3, you could write it as 3 squared. So we're going to practice a few of these. I'm going to show you how we can find this out. Alright, so we're going to look at 28, this number 28. If I asked you to use prime factorization on the number 28, we'll use a method that's called generally like the tree method. So think of 2 numbers that when you multiply them, you get 28. Okay? If you're like me, you thought 7 times 4. There are other ways to do this as well. Now we're going to check, are either of these prime numbers? And the answer is yes. 7's a prime number, so we're going to circle it. 4 is not a prime number. We're going to have to keep breaking that down. How can you multiply to get 4? 2 times 2. Are either of those prime numbers? Yeah, 2 and 2. Those are both prime numbers. So the prime factorization of 28 would be 7 times 2 times 2. That equals 28. Hopefully that makes sense. We'll look at another problem really quickly here. 40. How are we going to factor 40 into its prime factors? Well, if you're like me, you think of 40 as 20 times 2. Now 2 is a prime number. I'll circle that. 20, we can keep factoring it down. You might factor it as 5 times 4. You might factor it as 10 times 2. Either way, you'll end up getting the same answer. 5 is a prime number. 4 is not. I'm going to keep going. These are both prime numbers. I've now run out of things to break down, right? So 5 times 2 times 2 times 2. Now why are there 3 2's in there? Because I've got my 3 2's right here. 5 times 2 times 2 times 2. So here we have the prime factorization of 40. You're going to do some practice with this, and we'll see you in class. Thanks.